Kosyalan, Zaki, Sivasundram. Today we are gonna step 6 about DC motor, Servo motor. So let's jump to part 1. Part 1 is the simulation. This thing is get in the right here. Then we need to set the guided code, the Arduino ID, and observe what is coding all about. There's the simulator. So I push the anti-clockwise. Observation when the clockwise, but when the push button anti-clockwise, and it's the which is decreasing. Next is there for part 1 exercise 1. This exercise 1 is start and stop. And the speed can be adjusted by user, and the motor can only rotate in one direction only. This is the modified thing. The exercise 1. The motor it doesn't move. Push button to start it and stop it, and the DC motor will action. Just the potential. The DC motor speed is increasing. Next is let's jump for the part 2 is the simulation for servo motor. Is the same as the part 1. We need to circuit in the action. This as you can see. Then we need to setting the servo motor angle. Minimum is 0 degree and maximum is 180. Then we need to set this provided code in Arduino ID. And then we need to observe. Okay. The servo motor doesn't rotate. If I adjust this potentiometer, as you can see the voltage, value of the voltage is increasing. As I increase, I adjust the potentiometer to 100%. Maximum voltage is 5 volt, and the maximum degree for the servo is 180. And if I adjust the potentiometer to 0%, the voltage will decrease to 0. From the observation, when we run the simulation, we can see the servo motor will not rotate. The servo motor will rotate based on the potentiometer. If we increase the potentiometer 1%, the servo motor will rotate to 180 degree, and the jet voltage is 5 volt. When we set the potentiometer to 0%, the servo will rotate to 0 degree and measured voltage is 0 volt. And then from the simulation, we need to fill this table, and we also need to do manual calculation angle. This is the calculation for the angle and at this value. Next, by using the same circuit in figure 4, write the code as in figure 5. This is code. From figure 5, we need to apply in the Arduino IDE and run in the simulation in Proteus. Okay. From the observation from the simulation is when we run the simulation, we can see that the servo motor will rotate from 0 degree to 90 degree, 90 degree to 180 degree. After that, the servo motor will rotate back 180 degree to 0 degree. But the servo motor will stop for 2 seconds for each rotation. This is for the part 2 exercise 2. By using servo.h library, we write a program code that will rotate the servo motor based on potentiometer. So this is the coding. This is coding. Let's see the simulation. Okay. Let's adjust the potentiometer. It's 70% potentiometer. What happens if I decrease it? You can see the servo motor will split based on the value of the potentiometer. I adjust the potentiometer to 100%, the maximum degree is 180 degree. If I lower it to 0% potentiometer, I get back to 0 degree. Yeah, let's see. Next, right. That is for my part. Next part for part 3, I will pass on my partner, Kosyalan.
Hi, my name is Kosyalan Sivasundram. I'm from Beea section 1/2. Today I'll be explaining about for the lab embedded for part 3 simulation stepper motor. So by using Proteus, we create a circuit that's designed in figure 6. Then we'll use the Arduino IDE to write the program code. When we are done with that, we'll run the simulation, and from that simulation we can see that the stepper motor rotates 90 degrees in anti-clockwise following the sequence of A to A bar then B to B bar with a delay of 10 seconds before each transition. So as we are done with the first part of the experiment, now we'll move on to the second part, which is by changing the step angle to 10. So we click the double click the stepper motor, and then you can see I'm changing the step angle to 10. So after that we'll run the simulation. So as we can see from the simulation, after we follow the instructions above, the flow is still same to the same observation before this, but the stepper motor rotates 10 degrees in each sequence.
Okay.
So finally we move on to the final part of our simulation, which is modifying the program code given such that the stepper motor rotates in a reverse direction. So when we upload the modified program, we can observe that the simulation shows that the stepper motor rotates in reverse direction.